we're going to start making mathematical proofs. And a proof in math means that it's proven, period. All right? It's none of this beyond a reasonable doubt or anything like that. It's just, it's proven. It's either proven or not proven. Okay? Now, when you do a proof, the biggest thing that you need to put in there in your proof, and the most difficult many times, are the reasons. Okay? Because you can make a statement, and it can even be true. But unless you have a reason to back it up, it's not very convincing. So we're going to make in our proofs true statements, and we're going to have reasons to back them up. Because, you know, otherwise, like I said, otherwise it's just not very convincing if you don't have a reason to back it up. So that's what we got to concentrate on here. Now, reasons that we put in a proof tell why or how you know that the statement you made is true. So if I make a statement that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180, I have to have a reason that tells why I know that's true. It's probably the triangle angle sum theorem. Or if I state that angle 1 and angle 2 are supplementary, I need to have a reason. The reason could be because angle 1 and angle 2 form a linear pair, and linear pairs are supplementary. Okay? So you got to have reasons. Now, there are only certain things you can use reasons. The ones I just used were both theorems. But you can use some other things. Reasons in a proof can be any of the following. It can be given information. All right? In other words, we can just be told that. That's the information we're starting with. We're starting with these two triangles. We're given these two triangles. Okay? Could be a definition. Could be a theorem or a postulate. Could be properties. You know, what kind of properties? Reflexive, symmetric, transitive. Okay? So, all year long so far, haven't we been concentrating on learning definitions and learning theorems and learning postulates and learning properties? So now we can use those things as reasons in a proof. And these are the only things that can be used as reasons in a proof. Because I said so. Although a very good reason for me telling you to do something is not a good reason in a proof. Okay? So it has to be given information, definition, theorem, postulate, or property. Those are the only things you're allowed to use in a proof. Okay? Now, we're going to start off by proving that two triangles are congruent. So remember what we have to show to prove two triangles are congruent. From what we did in section 4.3, the way we tell if two triangles are congruent is if all 6 pairs of corresponding parts are congruent. Our intuitive idea of congruent is they're the same shape, same size. But our formal definition of congruent is that all pairs of corresponding angles are congruent and all pairs of corresponding sides are congruent. So to prove that two triangles are congruent, we'll have to show all 6 of those pairs of corresponding parts are congruent. Let's do one. This is actually number 8 from page 257. So, write this down. You're going to need an example of a proof. Wherever you want to put it. Now, on page 257, number 8, the directions say write a paragraph proof. We will, but not yet. We're going to start with what is called a 2-column proof. Guess how many columns a 2-column proof has? Yeah, it's 2. I know somebody said 3, but no, it's just 2. Okay? One column is statements. The other column is reasons. The statements are the facts. The reasons back them up. Okay? Now, when you do a proof, there's a lot of writing. You're going to have to get over that. Okay? There just is. So, the first thing you do when you write a proof is you write down what's given. So, on your paper, you should write given. Angle WXZ is congruent to angle YXZ. Angle XZW is congruent to angle XZY. Segment WX is congruent to segment YX. And segment WZ is congruent to segment YZ. And I'll give you a minute to finish writing all that down. Now, they've given us 4 statements. They've given us 2 pairs of congruent angles and 2 pairs of congruent sides. Those are facts, okay? And we're going to put them in our proof. And our reason is going to be given. All right, so things that you're given, they're true. You don't have to wonder if they're true. They're true, okay? Now, so the given's important. That's knowledge that we have to get us started on our proof. Now, you also got to keep in mind what it is you're supposed to prove. For this particular problem, we're supposed to prove that triangle WXZ is congruent to triangle YXZ. So, write that down. Prove triangle WXZ is congruent to triangle YXZ. And considering this is geometry class, we're almost always going to have a figure to go with our proof. Okay? So, draw the figure. I put it down below because that's where I had room. If you notice in the book, they put the figure kind of beside the given information and what you're supposed to prove. Doesn't really matter where you draw the figure, but you're going to need to draw the figure. It's going to help you figure out what you need to put in your proof. So on all the proofs, you do need to draw the figure. It's not a waste of time. It's not. Not at all. It's vital, as a matter of fact. Now, before we get on our proof, well, let's even do this. Make your 2 columns. Column on the left is statements. Column on the right is reasons. And before I start writing my proof, I'm going to think about it first. I'm going to plan, okay? Sounds like things you do in other classes before you write, doesn't it? I need a plan. I got to do some thinking about what I'm going to do. All right, to help me make my plan, I'm going to mark on my figure all of the given information. So the first thing I'm given is that angle WXZ is congruent to angle YXZ. I'm going to label that on my figure. Angle WXZ is that one. Angle YXZ is that one. So that's one pair of congruent angles. Also, angle XZW, this one, is congruent to angle XZY. This one. So that's another pair of congruent angles. Next, they tell me that segment WX, right here, is congruent to segment YX, right here. And segment WZ, down here, is congruent to segment YZ, here. So, I've got all the given information. I'm staring at it. I've got all the given information labeled on my figure. it's time to look at what I'm supposed to prove. I'm supposed to prove that triangle WXZ, so that'd be the triangle on the left in this figure, is congruent to triangle YXZ. That's the triangle on the right, isn't it? Okay? What does it mean for two triangles to be congruent? It means that all three pairs of corresponding angles are congruent and all three pairs of corresponding sides are congruent. So that's 6 pairs of corresponding parts altogether. Hey, we got 4 of them, don't we? So they gave us a lot of information here. Remember something else. It's corresponding parts. So by looking at what I'm supposed to prove, remember how that congruent statement, that's called a congruent statement, tells you what corresponds to what? So I can tell by what I'm supposed to prove, by the congruent statement I'm supposed to prove, I can tell that angle W corresponds to angle Y. And the angle X in the triangle on the left corresponds to the angle X in the triangle on the right. And the angle Z in the triangle on the left corresponds to the angle Z in the triangle on the right. Then I can tell segments as well. Segment WX corresponds to segment YX. Segment XZ corresponds to segment XZ. Who would have thought that a segment would be congruent to itself? Segment WZ corresponds to segment YZ. So I need to keep all that in mind. I have to match everything up correctly, don't I? All right, all the given information matches up the way it's supposed to, doesn't it? Every bit of it. It had better, okay? It will. The given information won't trick you. It will, and it does. So I'm thinking all I need to do is come up with one more pair of corresponding angles that are congruent and one more pair of corresponding sides that are congruent, and I've proven the triangles are congruent, right? Because that'll be all 6 pairs of corresponding parts. That will prove the triangles are congruent. So I got to put it all in my proof. First step of the proof is always easy. Put your given information in there. So step 1, angle WXZ is congruent to angle YXZ. I know that's true because it's given to me. That's one of the 5 reasons I can use given information. Now, and this is kind of unique. You might not be expecting this. Whenever I have other facts I can state that have that as the reason I know they're true, I can list them all as part of statement 1. So statements can contain more than one fact at a time as long as they all have the same reason. Okay? So what else is given to us? Well, that other pair of angles is given to us. So angle XZW is congruent to angle ZXY because of the same reason. It's given. That's why I know it's true. Well, I can go ahead and list the 2 pairs of congruent sides as well. And that I was able to fit on one line. Not that it's important to save a line, but I'm trying to make it all fit on one screenshot. So segment WX is congruent to segment YX because it's given to us. And segment WZ is congruent to segment YZ because it's given to us. So at this point, we have 4 pairs of corresponding parts that are congruent. We need the other 2 pairs. Okay? Everybody with me? Does it all seem nice and logical? I mean, that's what it is. It's an exercise in using logic. Okay? All right, so let's get one of those other pairs of corresponding parts that are congruent into my proof. I'm going to do the angles. Angle W is congruent to angle Y. And I can name them just using the vertex because there's only one angle W in the figure. There's only one angle Y in the figure. My reason, well, it's not given to me, so it's not given. I can use a definition. Well, there's not a definition that tells me those 2 angles are congruent. I don't know what their measures are, so I can't do that. I can use a postulate. I don't have a postulate that says it. A theorem, I do have that. The third angles theorem tells me why angle W is congruent to angle Y. Do you see that? Look at the figure. Don't I have two angles from the triangle on the left congruent to two angles from the triangle on the right, the third angles theorem says that means the third angles are also congruent. So I know for a fact that angle W is congruent to angle Y because the third angles theorem tells me so. So the third angles theorem tells me why it's true that angle W is congruent to angle Y. Okay? Make sense? All right. I need another pair of congruent sides. Well, look at it. Look at everything that's marked. WX is marked as congruent to YX. WZ is marked as congruent to YZ. The other side of the triangle on the left is segment XZ. The other side of the triangle on the right is also segment XZ. Do I know for a fact that segment XZ is congruent to segment XZ? Yes. Not because of given, not because of a definition, not because of a postulate, not because of a theorem, but because of the reflexive property. So my next statement, number 3, is that segment XZ is congruent to segment XZ. The reason why that's true is the reflexive property. Reflexive comes up a lot in these proofs. Okay, comes up a lot. So, let me see. I guess I can mark that congruent to itself like so. Do I have everything I need to state that these two triangles are congruent? Yeah, not only do I have all 6 parts, they worked out in the exact order they were supposed to so that that congruent statement is true. This angle W was congruent to that angle Y. This angle X here was congruent to that angle X there. That angle Z to that angle Z. That side WX does match up with YX. WZ does match up with YZ. XZ does match up with XZ. They all matched up just like they were supposed to. So all we got to do now is say it. The fourth and final statement. Triangle WXZ is congruent to triangle YXZ. And the reason I know that is true is because of the definition of congruent triangles. Our definition said that all 6 parts of all 6 pairs of corresponding parts had to be congruent to prove the triangles are congruent. Any questions? We're good? Hooray! You've done a mathematical proof now. Pat yourself on the back. Okay. If we had to use the definition of congruent triangles every time we needed to prove that a pair of triangles are congruent, that'd get really old, wouldn't it? So fortunately for us, there are some methods that are, well, half as much work. We had to come up with 6 pairs of corresponding parts that are congruent to do a proof using the definition of congruent triangles. We're going to learn 4 methods for proving triangles are congruent that involve half as much work. They involve 3 pairs of corresponding parts that are congruent. But it's got to be the right 3 pairs. Okay? It's not just any old 3 pairs. It's got to be the right 3 pairs. So, in section 4.4, we have 2 learning targets. We're going to use the side-side-side congruence postulate to prove that 2 triangles are congruent. And then we're going to use the side-angle-side congruence postulate to prove 2 triangles are congruent. So turn on over to page 262. We're going to learn side-side-side and side-angle-side. before we get to those specifically, previously, we proved that two triangles are congruent by showing that all 6 pairs of corresponding parts are congruent. I mean, we just did it. It is possible to prove two triangles are congruent using fewer pairs. In this section, we will use side, 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 and side, angle, side. In the next section, we will learn to use angle, side, angle, and angle, angle, side. So there's your 4 methods we're going to learn. We're going to learn 2 of them in this section, 2 of them in the next section. You can always use the definition of congruent triangles like we just did. That'll always work. You can always use it. So why do we have these? Because we can do it with less information. Okay? And so if we can prove something is true, I mean, and again, remember, if it's proven, it's proven. There's no wiggle room. There's no doubt at all. If we can prove something true with less information, well, then that's a good thing. Okay? All right. Let's learn our methods. Side, side, side. On page 262. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. Okay? That's why it's called side, side, side. 1 pair of congruent sides, 2nd pair of congruent sides, 3rd pair of congruent sides. Side, side, side. Okay? And look, this isn't a proof. This is just showing. But see how that triangle fits exactly on triangle ABC? So if I move that, let's see, I think I need to flip it, don't I? Over to here. See how it fits perfectly on that one as well? Those 2 triangles really do have the exact same size and shape, don't they? We don't know a thing about their angles, not a single thing. But the mere fact that all 3 pairs of corresponding sides are congruent is enough to prove that those 2 triangles are congruent. With me? Okay. So you got to be able to match up the corresponding sides, don't you? So here they did that for us. Oops. All right, segment AB. Let me move this out of the way. Segment AB here is congruent to segment DE. So that's 1 pair of corresponding sides congruent. Segment BC is congruent to segment EF. So that's our 2nd pair of corresponding sides congruent. And then segment AC is congruent to segment DF. That's our 3rd pair of corresponding sides congruent. And as we just saw using this, that's enough to prove that the 2 triangles are congruent. Okay? I think I told y'all this before, but let me say it again just in case. Doing this kind of thing, moving this around, is what our state standards call using rigid motions. They're actually called transformations. When you flip something or slide it or turn it, which is a rotation, those are transformations, which rigid motions. Rigid because nothing changes size. Okay? So if you can do some sort of transformation, some sort of rigid motion to turn one triangle into another triangle and they're identical, well, that means they're congruent to each other, doesn't it? Okay? Nothing changed size. Just the one of them's maybe oriented differently on your paper than the other one. But if you can, and I know you can't do this, you're on paper, you don't have the magic smartboard thing here. But if you can just move one, to the other, and those be identical, well, then that means the triangles are congruent. Triangles are identical. Okay? What say we do a proof? Number 6, from page 267. we're going to use the side-side-side congruence postulate to prove two triangles are congruent. So for number 6, they tell us to write a 2-column proof, which that's good. That's what I wanted to write anyway. And look at all the given information. So begin by writing down your given information. And write down what you have to prove and draw your figure. All right. I'm going to label this as you guys finish your writing. I'm going to have, I know it's labeled, but I'm going to label it myself because just by labeling it myself, it really does help me realize what I know and what I need to know. Okay? So segment AB is congruent to segment ED. Segment CA is congruent to segment CE. And then segment AC bisects segment BD. Now, what happens to a segment when it gets bisected? Well, if it's a perpendicular bisector, it's a right angle, but it definitely gets cut in half. Okay? So, segment AC right there, well, I guess the segment stops at C, doesn't it? Segment AC bisects segment BD. If segment BD gets cut in half, what are we going to be able to conclude about segment BC and segment DC? We're going to conclude that in just a minute, aren't we? Okay, I guess I won't label that yet, but we're going to need that, aren't we? All right, so we're ready to move on, start our proof. Okay, we've got statements, we've got reasons. What do we put as our first statement? Given. Put the given. Very good. Y'all picked it up from just one example. Put the given information first. So our given information is that segment AB is congruent to segment ED, segment CA is congruent to segment CE, and segment AC bisects segment BD. The reason for all three of those is given. The only time you put more than one fact in a statement is when they all have the same reason. As long as they're all given, we can put them all as statement 1. All right. We don't have to mess with angles because we can use side, side, side. And we've already started planning it out how we're going to use side, 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 right? The fact that segment BD gets bisected is going to lead us to having another pair of congruent sides. We got to put it in our proof, though. Now, this gets a little picky. Okay? Proofs are picky. So, before I can say that segment BC is congruent to segment DC, I have to point out that C is the midpoint of segment BD because, and different books do this different ways, but the way our book defines a segment bisector is something that goes through the midpoint of a segment, and then the fact that C is the midpoint leads us to conclude that segment BC is congruent to segment DC. So, I mean, that is a technicality. I know it's a technicality. It's an important technicality. You can't ignore the little details, okay? And the little details will get you. So be careful, okay? Because you can understand the proof, and you can make a pretty convincing proof, And if you've left off one little detail, it's not really a proof. All right? So, C is the midpoint of segment BD. The reason, definition of segment bisector. Our book defines a segment bisector as a line, ray, segment, or plane that goes through the midpoint of a segment. So that means C is the midpoint of the segment. That leads us, maybe it doesn't lead us to anything. I'm not going to say it again. That causes us to know this, that segment BC is congruent to segment CD, and I gave two different reasons because I'm trying to look ahead towards the ACT, the potential end of course exam that will eventually be in geometry. And some books call that the midpoint theorem. Some books call that the definition of midpoint. To be honest, I don't even remember which one this book calls it because I've called it both things using different books. So I'll take either. In fact, I'd rather do definition of midpoint, but I'll take midpoint theorem. Okay? So I don't, like I said, I don't even know which way our book calls this, but either one. You don't have to put them both. You don't have to do what I did and put them both. Either one I'll take. Okay? Is that everything? What else we need? Yeah, we got to say it, don't we? We got to say that triangle ABC is congruent to triangle EDC. And our reason is not definition of congruent triangles. It's the side-side-side congruence postulate, which we will all just put SSS for side-side-side. That's right. It's because this postulate says all I need are 3 pairs of congruent sides, then the triangles are congruent. On the first one we did, if we'd have known the postulate, okay? All right, everybody understand that? The reason we did the first proof the way we did it is because we'd never heard of side-side-side at that point, so we had to do the definition of congruent triangles. So at this point, really, we have two methods that we've practiced. We've practiced definition of congruent triangles. We've practiced side-side-side. Okay? Does that make sense? Everybody with me? All right. Another method in this section is side-angle-side. If you look here on page 264, they explain to us what an included angle is. It says the angle formed by 2 adjacent sides of a polygon is called an included angle. An angle formed by 2 adjacent sides of a triangle is called an included angle. It says consider the angle JKL formed by the hands on the first clock shown below. Anytime the hands form an angle with the same measure, the distance between the ends of the hands, JL and PR, will be the same. So this angle K is the included angle between sides KJ and KL. Well, over here, that angle K is the included angle between sides KP and KR. So included angle is simply the angle formed by the 2 sides we're talking about. Okay? Triangle has 3 sides. We'll talk about 2 of those sides. Any 2 sides form one included angle. For instance, if we call this triangle XYZ, angle X is included between segment XZ and segment XY. But angle Y is included between segment YX and segment YZ. See how that works? Angle Z is included between segment ZX and segment ZY. So they're all included angles, but for any two sides, there's one included angle. With me? Okay. The side angle side congruence postulate says this. If two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. Okay? Now, two sides and included angle. Well, okay, I'll do it that way then. All right, we have two sides and that included angle. See the green? Those two sides and that included angle, let's see, I'm going to have to flip it again, all right. Are congruent to those two sides and that included angle. According to this postulate, that's enough to prove that those two triangles are congruent. Let's see if it is. Come on. There, got it. Almost. Ta-da. Okay? So it really works. All we knew were two sides and an included angle, congruent to two sides and the included angle. Okay? Now, why is it called side, side, side instead of the two sides and the included angle? Well, first of all, side angle side. Side angle side is easier than calling it the two sides and the included angle postulate. But they're wanting you to trace it out with your eyes. With your eyes, don't write in your book. Side, included angle, side, corresponds to and is congruent to side, included angle, side. Okay? So with your eyes, you look at it as side, angle, side. Okay? Does that make some sense to you? You'll get better at that as time goes on. Trust me, you will. You'll get good at that. All right, let's see if we can do one. Number 3 from page 266. In the exercise diagram, if segment LP is congruent to segment NO, and angle LPM is congruent to angle NOM, and angle MOP is equilateral, write a paragraph proof to show that triangle LMP is congruent to triangle NMO. Wow. All right, so here's where we start. And I didn't leave myself enough room, but I'll make it fit in. We got to figure out what's given. So we're given that segment LP is congruent to segment NO. We're also given that angle LPM is congruent to angle NOM. And we're given that triangle MOP is equilateral. We have to prove that triangle LMP is congruent to triangle NMO. and we draw the figure. And let's label the figure. Segment LP is congruent to segment NO. Angle LPM, that'll be this one here, is congruent to angle NOM, this one. And I don't really know how to label that triangle MOP is equilateral, other than labeling that all three pairs of its sides, or all three sides are congruent to each other. So that one, and that one are all congruent to each other. Now, look at the two triangles we're supposed to prove. I'm making my plan now. Look at the two triangles we're supposed to prove are congruent. Triangle LMP and triangle NMO. Can I prove those two red triangles are congruent? In fact, don't I have all the information I need? I just got to say it right. Okay? So, they want us to do a paragraph proof. All a paragraph proof is, instead of statements and reasons as separate columns, you make sentences out of your statements and your reasons. Like this. It is given that segment LP is congruent to segment NO, and that angle LPM is congruent to angle NOM. So instead of stating the two things and then putting a reason given, I just wrote it as a sentence. It still has a statement and a reason, doesn't it? So we never get away from statements and reasons, even when we write sentences. All right, I want to state that segment MO is congruent to segment MP. That gets us our second pair of congruent sides. So, since triangle MOP is equilateral, so that's the reason, then segment MO is congruent to segment MP. Well, in fact, part of the reason is triangle MOP is equilateral. The rest of the reason is definition of equilateral triangle. All right, so the first part of the reason is that triangle MOP is equilateral. The second part of the reason is the definition of equilateral triangle. Put that together, you got segment MO congruent to segment MP. That means that triangle LMP is congruent to triangle NMO by side angle side. Because look what we did. We had one pair of congruent sides, then we had a pair of included angles congruent, and then finally we had the second pair of congruent sides. It's got to work in that order, though. It's got to be the two pairs of sides congruent, and the angles that are congruent must be the included angles. They can't be off somewhere in another corner. It's got to be the angles that are formed by those sides, by those particular sides that we've listed here and here. Any questions? Good. Let's see. Yeah, we can wait on that one. And there's your assignment.